Hi students, in this lecture I will teach you that how you can export data from MATLAB. So I will first export data in the shape of .mat file. I will also teach you that how you can load this .mat file back to the MATLAB. Suppose if I have some data like it is a matrix, and that matrix is a consists of some values. These are some random values. So when I execute this line of code, you will see a matrix has been generated, and you can see the result in the command window as well as in the workspace. So this is the matrix M. I want to save this file. I want to save this matrix as .mat. So what I will do is I will just simply write save, and I will write M, then comma, then again the name of this file. So when I write the first M, which is the file name, suppose if I want to write the name of this file is export data, still the result would be similar. Now when I run this code in the current folder here, you will see a .mat file will appear. So this is our current folder. Here that file will be generated. So when I run this code, you will see here a .mat file will appear. So this is the .mat file. This export data.mat, it stores the content of this variable M. So if I clear the workspace, like I have cleared all the variables, there is no any variables in the workspace. So I have written incorrectly. I will write clear all, so that all the variables are clear from the workspace. Now there is no any variable. In order to load this variable, we will just write load, and we will write the name of this variable. So we will write this thing. When we write this and we execute this, the same contents will be loaded into MATLAB. So this is the method to export and import this data into MATLAB. So if we write this line of code, the data which is stored in M, this content will be exported as a .mat file. When you write this line of code, which is load and the name of the file, then this data will be imported back into MATLAB. And when this data is imported, the name of the file will be same, like the name of the file in the workspace, the name of the variable in the workspace will be M, because M is stored in this file. So the content of M is stored in this file. Now I will show you that how you can export CSV file and the content of this variable into .csv file. So what I will do is I will just simply write matrix. When I write this thing, I will first write the name of the variable, which is M. Then I will write the name of the file, like I'm going to save it with the name matrix m.csv. When I run this line of code, a CSV file will be generated here with this name. You can see this file has appeared in the current folder. So here this data has been generated. This is the .mat and this is the .csv file. So these are the two simple methods. If I have to export some data as a .mat, or if I have to export that content as a .csv file. So if I load it in this shape, like just drag and drop, that content will be shown up here. Like this is the content of variable M, which could be seen up here. So through this way it is imported as a table. Like you can see here, matrix.m is loaded as a table. And as you already know that there are two methods of importing .csv file. The one is load data, import data, and the other is load matrix or import matrix. So I have already shown you in the previous lectures. So in the next lecture I will show you some more methods how to export the data, like how to export an image into a folder. If I want to export this file, this .mat file, into this folder here, this is our folder. If I have to export this into this folder, images, what I will do is I will just simply write the name of the folder here. And this file will be exported into this folder. Now you can see that the .mat file is present here. And similarly, if I have to export the CSV file into that folder, I will just define the complete path along with the file name. You can see up here this file has been created. So by using this method, you can just copy some files from one folder and export them into another folder. So you can organize your data by making a simple code in MATLAB. You just have to define the path of the folder or the file, and from that path you can import all the data into MATLAB and then export into your desired folder. So you can reorganize all your files by simply writing a few lines of code in this MATLAB. In the next lecture I will tell you that how you can export images into the into your drive, or how you can import images, you can process them, and how you can export them back. Thank you so much. Hi everyone. In this lecture I will generate an image and then I will write that image into a folder. So first I will create an image. I'm going to create a red image, like the pixel intensities will be red. So what I am doing is, as I have told you that how you can create a matrix in MATLAB. So I am going to create a 3-channel matrix, which the first channel will store all the values which have intensity as red. So when a pixel have store a value with 255 in red and 0 in green and 0 in blue, then this pixel will be of red color. Here I want to create an image of size 256 cross 256 pixels, and its intensity, its color intensity should be red. So I will create ones, and the dimension is 256 by 256, and this is the first channel. So the first channel should be having intensity 255. So when I run this line of code, a 256 cross 256 matrix will be generated, and that matrix will store the value which is 255. So you can see that every pixel intensity or every position store a value of 255 here. Now I have to store some more data into this matrix for the green channel. So the green channel is channel number 2. So I will store 0 in this channel. So I am going to multiply this with 0, or I can create a zeros 256 cross 256. Both mean the same thing. So when I generate this, the dimension of this matrix in the workspace will change, and you will see a different thing here. Now it's a 2-channel matrix. Since the RGB image consists of 3 channels, so I will generate the third channel, which also consists of zeros. Now you can see here a 3-channel matrix has been generated. As we know that the matrix which store the image, its data type is unsigned integer. So I will use the typecasting, as I have already told you that how you can use the typecasting. So I will write uint8 and then I will write the name of this matrix. So through typecasting, this image will be converted into 8-bit. So this is an unsigned integer 8-bit data type. Now if I have to display this image, I will just simply write IamShow and then I will write the name of the variable, the name of the matrix or the name of the array. So when I run this line of code, a 256 cross 256 image will be generated. This is a 256 cross 256. Since you know that the red image have the pixel intensity high at the red position, for the green and blue values of this image are zeros, like these are the green and blue positions. If I want to change this into green, I will switch the first channel to 0 and I will convert the second channel to 255 and I will keep the third channel as 0. When I run this line of code, a green channel will be generated, a green image will be generated. So now you can see a green image has been generated. If I have to switch this into blue, then I can convert the blue intensity into 255 because the 0 mean black and the 255 mean white. So when the blue channel has high values while the red and green has low values, then the image will be shown as blue. Now you can see this is a blue image. If I have to mix some more colors within this image, like if I have to put some redness into this and I want to have the redness of 100, there is no greenness, so the image is 100, like the image intensity and the pixel intensity is 100 red, 0 green and 255, which is the full range. It's blue. So how this color will now look like, let's see. Now you can see that by adding little redness, now the image color has changed. If I reduce the blueness of this image, I change it to 100 and then I see that what has been formed. Now the pixel intensity of the image has changed. Now it's look like a magenta color. So this is the method for creating different colors within the image. Now I would like to export this image into a folder. So how I will export it? So to export this image, I will just write I am right. I am right. I am right mean to write this image. So the image name is M and the file name where I want to store is the name of this file would be i.png. So this image will be exported into this current folder. If I give some more path in the file name, then it will be exported into a different folder. After this execution of the code complete, the image will be found here in the current folder. So this is our current folder. This is our current folder and you can see an image has been created here. You can see if I open it, you will see that this is the same image which I have created in MATLAB. If I go into the properties of this image, you will see that the dimension of this image is also the same which I have created in MATLAB. Its dimension is 256 cross 256. I can increase this resolution by changing these values. If I increase these values, the resolution will be increased. If I want to save this image into this folder, I will simply write the name of the folder. If I have to save into any other folder, I will just simply write the path from the root to that folder, and that image will be stored up in that folder. Now when the execution of this code get completed, the image will be generated into here, up here. So you can see that the file or the image has been exported into this folder. So this is the complete procedure that how we can export an image into any folder in our drive. So you can transform in this complete code. We have generated image of 256 cross 256 resolution with different colors, and then we have transformed its data type by using typecasting. We have converted into unsigned integer 8, and then we have displayed it and exported it. Now if I have to find the size of this image, you can see that there are 256 by 256 pixels, and you can see that this is an RGB image. So each bit is stored, so each value is stored within 8 bit. 8 bit mean 1 byte. So the image size will be 256 times 256 times 3. So these are the total number of bytes for which this image would be consist. So if I convert it into KB, the image size would be 196 KB. If I check in the folder that what is the dimension or what is the size of this image, so it shows up here that it is 4 KB. 4 KB mean that its size seems to be double, like it's not what it has been calculated up here. So it is different because of the PNG formatting. If I save it as a .mat, then the size or the dimension of this would be like 19 KB. If I save it as a .mat like this, then the dimension or the size would be different, since we have some compression method which has been applied. So this encoding has compressed the image size to 4 KB. In the next video, I'll show you some more methods to export data from MATLAB. Hi everyone. In this lecture, I will teach you that how you can export a table into a text file and into a CSV file. So for that, I will first create a table. So for the table, I need some data. For example, I have some stock data, and the stock has some 3 different type of materials. So I will write serial number with S N O. So I have a serial of 4 different materials. So the first column of the table will consist of the serial number, which start from 1 and end at 4. Then the names of the stock, or I can write stock name. So I will write the stock names with string. So in order to write the name of the stock, I will use these cells. So within these cells, I will write the name of every stock. Suppose we have a factory. Within this factory, we have some raw material. For example, we have iron. The first serial number 1 is iron, and the serial number 2 is copper, and the serial number 3 is aluminum, and serial number, which is the last serial value, it is silver. So we have these stocks. So I have to write the quantity of this stock. So the quantity of this stock is, I will write the name of the quantity, amount of quantity. Suppose it is in ton, so we have 1.5 ton of iron, we have 0.5 ton of copper, and we have aluminium 2 ton, 2.2 ton, and we have silver which is 4 ton. And the fourth column represent the price of the item. So suppose I have the price in dollars, in US dollar. Suppose the price of the first one is $1,500. The price of the second is $6,000. The price of the third one is $2,000. And the price of the last one is $1,800. Now I will create the table by using this data. So in order to create this table, I will need some more information. So the table will consist of, the table name is T, or I can write table 1. And in order to create this table, I will have to write the main keyword, which is table. So within this, I will write the name of the quantity that I want to add. Now as you know that I have created a table, the name of the table is table 1. By writing table and including all these variables which have been listed up here. The first column is the serial number, the second is the stock name, third is the quantity, and fourth is the price. And running the code, it generates this table. First column, serial number, stock name, quantity, and the variable name have been shown up here as the header of the table. So now I want to export this table. So in order to write this table as a text file, what I will do is export table as .txt file. So for that I will use write table, and I will write the name of the table, and then I will write the name of the file. So the file name at which I want to store this text file, I will define that variable. So the file name is equal to table.txt, or I will write table stock. So I will write table stock.txt. So this is the name of the table. I will put it in the colon because it should be a string file. When I run this code, you will see in the here. So the name of the table is table 1. So I will write table 1. When I run this code, you will see a table would be generated as a text file here. So the name of the table is table 1. So I will look into this file. Where is it? The name of the table is table.stock. I will run this code again, and I will look into it that whether the file has been generated or not. So I have made a mistake. This should not be within the colon because this is the name of the variable. When I run this code, you will see that the table has been generated, and I can see it within the file, which is, I will see it in the folder. So the folder is this one. So this is the table stock. So you can see that a table has been exported as a text file. Now I want to export this table as a CSV file. So I'm just trying a random guess that what happens. I will tell you that what happens. Write table. I am going to write the name of the table, which is table 1, and then I am going to write the name of the file, table export dot csv. Now I will run this code and I will see that what happens. So you can see that the file, the table has been exported as a CSV file. If I run this, if I open this, you can see that the table has been exported as a CSV file. So this is the table which I have exported as .csv file, and this one is the text file which I have exported. If I have to export it into a folder, I will just write the complete path within the file name. So there are two methods: either define the path within a variable as a string, or you can directly write it up here. So this is the name of the file. For the name of the file, you can write the complete path from the root folder to the last folder where the file you want to store, and or either you can start from this current folder and put it where you want to save it. So this is the method for exporting table into .csv and .text file. In the next lecture, I will tell you some more detail about exporting data from MATLAB. Hi everyone. In this lecture, I will be teaching you that how you can import data into MATLAB directly. Like, you do not use any command, just you copy data and paste it into the MATLAB. Suppose I have two Excel files. The first one is X and the second one is Y. I have two files. I want to import this data into MATLAB. So what I will do is, I will go to the MATLAB, and in here in the workspace I will create a variable. I will name as X, and I will create another variable and I will name it as Y. I am going to comment this section because it is used to clear the workspace. I don't want to clear the workspace because I have to generate data. I have to import data into the workspace. So I would not use this command. I'm going to comment it. Now I have this X. When I double click it, it is open. I want to import data directly, so I will copy this data and I will simply paste it here. Similarly, for the variable Y or for the vector Y, I will just only copy this data and I will paste it directly right here. Now you can see that the X and Y variable have been updated. So this way I can import external data into MATLAB. Now I can use this data. For example, if I have to display this data, this is here. I can process this data, like I can multiply this, I can make square of this data like x square. So this is a matrix, so I will use the dot operator. So all the values are individually square. I can add x with y with 2 steric x. I can make a big expression like z is equal to x whole square plus y square, y cube, and I can make a whole raised to the power 2 or square root 0.5. So I can write it like that. Since these are matrices, so I will always have to use this dot operator. So I can process this data anywhere. Because I have imported it, I can now process it in MATLAB. So this is the simplest way to import data, numerical or integer data, into MATLAB. You can also import complex data, which includes you can also import some more data, like suppose here I have some data like A, B, C, and D. Let's try to import this data into MATLAB. I am going to create a variable C is a variable which store the characters. So I am going to import some data into it. Maybe it gives me some error. Let's try it. You can see that the data on the clipboard cannot be pasted into this array because this array can only store text. So if I declare a variable C equals to A, and now I am going to try to paste this data. Now I can paste it, like when this is a character array, then I can paste the data into it, but it will be just in a one, it will act like a string. So in this video I have shown you that how you can import numerical data directly into MATLAB. In the next video I will show you some more commands through which you will import data properly through from anywhere in your drive into MATLAB. Stay with us. Hi everyone. In this lecture I will teach you that how you can import data from the text file. Import .txt file into MATLAB. So sometime we need to load text file into MATLAB and we have to process that data. So how will we do that process? I have a text file. If I open it, you can see we have some data. From day 1 to day 7, we have 7 columns. And within each column, we have some numerical data. Each data is separated with a single space. You can see here, the data within the row is separated with space. So, the delimiter in this case is space. The data which is stored in the drive is named as w.txt. If I go to the properties, you can see it is a text file. .txt is its extension. So if I have to import this data into MATLAB, what I will do is, I will write the name of this file. The file name is w.txt. I will put it in the single colon. Now, as I have written the name of this file, I need to write the delimiter name. So I can create a variable, whatever is its name, but I can write delimiter name, or I can simply write delimiter, or I can write delimiter, whatever is its name, I can write it. So the delimiter in this case is a single space. So what I will do is, I will put a space within single quotation. The third thing which we have to write is the header line. In this case, we have a text file with a header line consisting of text which start from day 1 and end to day 7. So the header line I am going to represent with head line. So the header line in this case is the first line. Now I have to import this data into a variable or into a matrix M. I can name it whatever I like. So I will write import data. And I will put the name of the file in the parentheses. So the file name, I will write it file name. Then I will write the name of the delimiter. So in this case, the delimiter is named as delimit, L-I-M-E-T. And then I will put the header line, which in this case is headline. When I run this code, we can see we have got a structure in MATLAB, and that structure consists of data, text data, and column headers. So if I have to extract only the data part, so I will create a variable. The name of that variable is data m. So it will extract data from that structure. So I will write m, and the input argument or the pointer which I am using is highlighting the data. So I will write dot data. So when I run this code, within the workspace I get the data. So if I have to write or if I have to use this data, I can use it within my code, or I can display it like this. I will write data m in the command window so we can see that data. If I have to find what are the header lines, what was the header of this data, so I have another data variable within this structure, the name of which is text data, which consists of values from day 1 to day 7. So I can create another variable which is head m. So it will extract the header data, which is represented with text data, which is this one. So I will write text data here. When I run this code, I get two variables. The first one is data m, the second one is head m. So if I open the head m, I can see this data. There is another thing which is the m dot column header, which consists of the same data. So this is the procedure through which I can import data. Now, if my data consists of delimiter and that delimiter is not space, if that delimiter is a comma, for example, I have this data and I'm going to remove the header, and in this case the delimiter is a single comma. Now I have removed the header and the delimiter is also a comma. They are a comma separated values. Now if I have to import this data, I'm going to put 0 here, and the delimiter in this case is a comma. I'm going to run this code and I can see that I have got some data in variable m. Now in this case we don't have any header, so this line of code and this line of code gives me error. I will comment these two lines of code because I don't need, because I have already imported my data into variable m. There was no any header, there was no any text file, the data was directly separated with a comma, so I have just only written a comma here. So you need to know that what is the delimiter in your data. From that data, if there is any header, you can remove it. You can write just a header line. So in this way you can import any type of text data into MATLAB. In the next section I will show you some more procedure to import data into MATLAB. Hi everyone. In this lecture I will teach you that how you can import data into MATLAB. As in the previous lecture, I have teach you that how you can import text file into MATLAB. In this lecture, I will teach you some more methods how to import .csv file as a matrix, as a table. I want to import a CSV file into MATLAB, and that CSV file is this one. So this is the same data which was previously in a text file. I want to import this table into MATLAB. So first I will write the name of the file. The file name is x.csv, and then I will declare a variable t, and I will write read table, and that table is file name. So when I run this code, I will get this data in a table, and you can see that here we have a table. And if I look into the workspace, the size of the table is 5 x 7. If I open it, I can see this type of table, which consists of some text in the first line, and from the second line to the fifth line, or we can say that from line number 1 to line number 5, or from row 1 to row 5, we have text data, we have numerical data. These are the headers. So if I have to extract this data, this one, the first column, what I will do is I will write t dot x day 1, because the name of the first column was x underscore day 1 underscore. When I run this code, I will get the column data of the first column data here. I can save this in any variable like column 1. Since these are 5 values in a shape, 5 rows and 1 column, so if I have to update this data in the first column, what I will do is I will put some more values like 1, 2, 3, 4, 5. When I run this code, now you can see in the first column the data has changed. So if I have to change the data of the second column, then for that I will need to see the name of the second column. The name of the second column is x underscore data 2 underscore. So I will write 2 here, and then when I run the code, the second column data has changed. So if I have to change all the columns, then I will do it step by step. I will just copy this line of code, and I can change the content of the third line as well. Now the second and the third column content will change. So this was all about it, how we can import a CSV file as a table. Now if I have to read the content of the table as a text, then what I will do, I will just write t2, this is the second variable. I will just write read table, and I will then write the name of the file. So the file name is x.csv. So when I run this specific line of code, you can see that the data has been loaded, but it is in the shape of table. I want to load it as a matrix. So if we have to import .csv file is a matrix, then I will just write, instead of table, I will just write matrix. And when I run this specific line of code, we will see that the data has been loaded into that variable as a matrix. Now again, if I have to load the data from the CSV file as a cell, so what I will do is, I will just write read cell, and the data within the CSV file will be loaded as cell. If I run this whole code, you will see that the data has now been loaded as a cells. If you look into T3, you will see the data is in the shape of cells. There are curly brackets on the icon of the variable. Now if I look into this file W, which is a text file, I can also load a text file as a table. I can also load it as a matrix. Import .txt file as matrix. So what I will do is, I will create another variable t4 and I will write read text matrix, and I will write the file name here. Now the file name is different, so I can declare another variable with file name, or I can directly write the name of the file within the single colon. So the name of the file is w.txt. So when I run this specific line of code, you can see the data from the text file has been loaded into T4 as a matrix. Now again, if I have to load this data as a table, import data from .txt file as a table. Then I will create a variable t5 is equal to read table, and I will write in the curly bracket the name of the text file. So when I run this line, you will see the data has been loaded as a table. So this was all about loading .csv or .txt file into MATLAB. There were two different methods, read table and read matrix, which we have discussed. In the next lecture, I will tell you some more information which are used for loading data into MATLAB. Hi everyone. In this lecture, I will teach you that how you can import an image or a video file into MATLAB. So first I will load an image into MATLAB. So in the current folder, which is the MATLAB practical folder, this one, I have an image. The name of this image is img, and this is the image which I will be loading into MATLAB. If I go into this detail, I can see that the extension of this file is png. So I will load this file into MATLAB. So first I will write the name of the file which I am going to load into MATLAB. So the name of the file is img.png. So this file is in the current folder. So when the file is in the current folder, we will directly import by writing the name of the file. If the file is in any other folder, then we will have to write the name of the folder as well. I will show you in an example. For example, I have a variable im in which I want to load this image. So I will write imread. imread mean read the image. Which read the image? Which image? The name of which is stored in file name. So when I run this file, when I run this code, an array will be created in the MATLAB. It will be just like a 3D matrix. Since this is a color image, so the matrix will store the RGB values of the file. You can see here a variable IM which represent a matrix. This matrix store the pixel values of the image, and each pixel values is of unsigned integer 8, which means its value will start from 0 to 255. All the pixels will be within this range. If I open this image, I will double click on this variable name, and you can see that cannot display summaries of the variable. So it cannot display it here because it is a 3D and a 3D could not be seen up in this place. So if I want to see the content of this variable, since this is a 3D matrix, and in the previous lectures I told you that if you have to see the first channel or the first 2D section of this matrix, which is red channel, so I will first write colon, comma, colon. So all the rows and columns of the first channel will be displayed. You can see that these values are within the range of 0 to 255. So if I show you these values, you can see that many values are zeros, some are 255, some are 13, 128, but all the values are within the range from 0 to 255. Now, when I have loaded this image into MATLAB, if I have to show this image, I have to display this image, I will write IM show, and I will write the name of this variable. The name of this variable is IM. When I run this line of code, the image will be displayed in the MATLAB. So you can see that this is the image which I have loaded from my drive into MATLAB. Now, if I have to see the red channel of this image, I will just write colon, comma, 1. Since this is an RGB image, so I will see 3 channels of this image. Now as you can see that the code is running, the data has been loaded into MATLAB, but I want to see only the red channel. This is the red channel. It looks like black, but it is actually a red channel. The intensities when combined with all other channels, it affects the redness in the image. It provides redness to the image. Similarly, if I write 2 here, the green channel will be displayed. If I write 3, then the blue channel will be displayed. Now, as I have loaded an image into MATLAB, now if this image was in the JPG format, then I would have written JPG. If it is in TIFF, then I would have to write the extension of this image. Now, the image was in this folder. Suppose the image is in a different folder, then what I will do? For example, I have a folder and the name of the folder is images, and this image belongs to this folder, like I have stored this within this folder. Now if I have to load this image into MATLAB, now my MATLAB is pointing towards this current folder, and within this current folder there is no any image, so when I run this code it will give me an error. Now if I have to show the MATLAB that where the file is present, I will have to write the path. So the MATLAB will start from this path. It can start either from the root or it can start from this folder. So in this folder, I have another folder. The name of that folder is image. And within the image, this image is present. When I run this line of code, When I run this line of code, it gives me error because this slash creates an error. So the name of the folder which I have written is incorrect. It is images. Here is an S. So when I run this, again the folder name is incorrect. It should be images. Now when I run this, you can see that the image has been loaded into MATLAB. So you should be very careful while writing the path of the data folder and the name of the file. If you write it incorrectly, then it will give you an error. So this is the procedure if you have to load some data from a folder. In the next video, I will show you that how you can load a video file into MATLAB. So this was about the images. In the next video, I will show you that how you can load an image, a video into MATLAB. Hi everyone. In this lecture, I will teach you that how you can import a video file into MATLAB. So I have a video which is an MP4 file. I want to load this file into MATLAB. So how I will do it? First, I will write the name of the file. Since the file is in the current folder, so I will directly write the name of the file. So the file name is vid.mp4. So now I need to load this file into MATLAB. First I will create an object, and from that object I will read frame of the video in a loop, like every frame of the video will be loaded and it will be displayed, and then another frame of the same video will be loaded and it will be displayed, and so on until the video ends. So this lecture will be a little more complicated because I will have to show you that how you can use loop as well, because the video consists of multiple frames. So the sequence of frames, when displayed in a sequential order, it become a video. So I have to use loops as well within this video. So first I will create an object. The object of this video is object V. I will write video read, R would be capital. I will write video reader, and then I will write the name of the file. When I run this line of code in the workspace, I will get an object. So in the workspace, I have got an object here, and you can see the detail of this object. Where do you read with properties? The file name is vid.mp4 and the path within my PC is c/MATLAB practice. The duration of this video is 30.5267 seconds. And the current time is considered as 0. The video properties are that the video has width of 480 pixel and its height is 270 pixel. The video consists of a frame rate which is 30 frames per second, and the total number of bit per pixels are 24. So this video is in RGB 24 format. Now if I have to display this video, I will need to use the loop. First I will show you that how a single frame from this object can be extracted. Let's open this object. Within the properties and values, you can see all the details which I have already told you. So I have to extract one frame from this video. This video consists of multiple different frames, but I need to extract one frame, and just like an image is displayed, I will display that frame. So for that, what I will do is I will create a variable. I am going to create a variable as image, and I am going to write read frame. So it will read a frame from this object. The name of the object is object v. When I run this line of code, I can see a variable in the workspace, and that variable is just like an image. As I have shown you that how you can display an image, so I will write I am show, and I will just write I am. I will just only run this line of code. I don't want to run the complete code. So when I run this line of code, the first frame of the video will be displayed. So this is the first frame of this video. And as I told you that the dimension of this video is this one, 270 rows and 480 columns. These are the total number of rows and these are the total number of columns. Since the number of columns are larger than the number of rows, so the video frame look like a rectangle with more width compared to height. Now I will need to display all these frames of the video. So for that I need to put these two lines of code into a loop. So I need to use a loop on these two lines of code. So the method for creating loop is that I will need to write for, and then I will need to write end. So this is the structure of the for loop. But with the for I need to write a condition that from where this loop should start and where this loop should end. So if I write that this is the index of the loop, if I start from 1 and it ends at 10, then this loop will execute for 10 times and then it will end. But for now I need to see all the frames of this video. So for that I will need to create a variable which stores the total number of variables that exist within this video. Suppose I create a variable n, and n stores the total number of frames within this object, within this video. So I will write obj.v, then I will write a dot, which is an extension. So the total number of frames which exist within this video are stored in num frame. So this is the num frame where all the number of frames are stored. So now this loop will execute for all the frames of this video. As I have shown you that the first line number 6 read frame from the video and line number 7 show that frame. So I will copy these two lines of codes within this loop. Now when I run this code, you will see all the frames of this video. Each and every frame of this video will be loaded and then it will be displayed, and this process will continue. And you can see that each and every frame of the video is displayed. Now I will stop this code so that every line of code should not be displayed within the command window because it takes a lot of time. So I will close this or terminate this code, and I will write a semicolon here. Now I will run this code again, and we will see that the video is being displayed. You can see here the video has been displayed. The video is running now. So when all frames of this video are displayed, the video will stop execution. So by using this procedure, you can display any video within the MATLAB environment, or you can process the video as well. If you transform the frames of this video, or you transform or you change the pixel values of this variable within each frame, then this video would be changed. You can put any object within this video by changing the pixels values of this IM matrix. If you change these values, then the content of this video will change. So this was all about loading a video file into MATLAB. In the next lecture, I will show you some more detail about loading different type of contents into MATLAB.